So, lesson 3.7, we're talking about polynomials. Common Core standard is to identify zeros of polynomials and construct rough graphs. That's what we're going to do. Now, class wants to say hi to you, Simon. So, here we go, you guys. Say hi to Simon. Upside down. Hi, Simon. Crazy, huh? All right, there we go. Back to it. So, let's go ahead and take a look. So, first of all, I want you to notice one thing. There is no y. There is no y, so we will not be graphing. You will not be graphing this on an x, y. You will not. That is, you will not be graphing it on an x, y. There is no y value in this at all. So we're going to graph this on a number line, okay? Because it's just x values only, okay? So if we want to look at a number line, go ahead and draw my number line first. So it's going to go on a number line. It's not on an xy plane. There is no y value, right? So first of all, we need to know what I call our border points. Border points are like our zeros, okay? So we're going to look for our zeros, which are basically going to be called border points, okay? In our reading, we had steps. Move all terms to one side. That's been done. Factor. In fact, this one's been factored for us, okay? That's really nice. So, if it's been factored for us, we can get the zeros pretty easily, okay? 1 0 is going to be at x equals negative 3. But that happens twice, doesn't it? It happens at negative 3, and it happens at x equals negative 3 again. That's a double root because of the x plus 3 quantity squared. That's my double root, okay? I'm also going to have a border point or a 0 at x equals 2 and at x equals negative 1. All right, it's already factored, which is great. It's done part of the work for me. These are my border points at negative 3 again, 2, and negative 1. Okay, so now what I'm going to do is put down my border points. So I'm going to go my negative 3, I'm going to go my negative 1, and I'm going to go a positive 2, okay? We might have the numbers in between. Easiest way to do this, and I am here to help you. I really am. Easiest way to do this is to graph it like it is a y equals. Okay, so if we graph it like a y equals, and we know that this symbol here says greater than, right? We're going to be able to look at our graph and find out when the graph is above the x-axis. That's when it's going to be greater than 0, right? We'll find out when the graph is below the x-axis. That's when it's negative, all right? Now, one thing for sure, I'm going to put open circles at my border points. Open circle, open circle, open circle. Because we want to find out when the graph is greater than 0 but not equal to it. So the border points are where it is equal to, but this does not have an equal symbol. So we're going to use open circles. Okay, so let's graph this and check it out and see what it looks like, okay? So if I take my calculator, turn on, y equals, clear all that, and I'm just going to graph in. So I got to go parentheses, I'm going to go x plus 3 quantity squared, parentheses, x, subtract 2, parentheses, parentheses, x plus 1. Okay. Okay, and I'm going to go ahead, and a button I like is Zoom Standard because I changed my window last problem. Didn't I change my window? So I'm going to go to Zoom, and I go 6 because that's my standard window, and I just grab it, okay? Okay, there it is. Now, one of the things for sure is that you can see the double root. You guys see the double root? Touch and go. Remember how it bounces? There's my double root. So automatically, I already know that it's positive because remember, this says greater than 0. I already know it's positive here, okay? It's positive there. You guys agree? It's above. It's positive in this region also. It's negative in this region. I can just see it from the calculator, and it's positive here, okay? Another way you can do this, okay, if you don't see it, if you have a difficult time seeing it, is you go to your trace button. So, for instance, am I going too fast? Okay, if I go to my trace button, okay, if I go to trace, it gets really easy. So if I want to take a value, I can't check negative 3, but I can check negative 4, right? So I go negative 4, and I get a 18. Well, that's a positive value, right? So at negative 4, I'd have a positive value, okay? I can check anything in here. Let's say negative 2. If I go to negative 2, I get a 4, which is a positive value, right? I can check anything over here. Let's say 0. And again, negative 18. So in this region, it's negative. And of course, anything in this region, let's try 3. And I get 144, which is a positive value. Okay? So what did I do? Well, what I want to know is this. What's the original question? It says, solve the inequality, x plus 3 quantity squared times x minus 2 times x plus 1 when it's greater than or equal to 0. That's all of this. So now, in set notation, so I can shade. I can shade here, because all of this region is positive, and positive values are greater than 0, right? I'm going to shade all of this, because where it's positive, all of these numbers are positive, which means it's greater than 0. Positive numbers are greater than 0, right? So if I want to write this in two ways, one is, first, I'll do it in set notation, and then I'll do it in interval notation. So set notation is going to be like this. Negative 3 is less than x, which is less than negative 1, or x is greater than 2. That's set notation, right? Just using the symbols. Interval notation, which I like better. You probably like interval notation also. Interval notation is just going to be like this. I will go parentheses because it does not include. I'd use a bracket if it was a solid dot. I'll go negative 3 comma negative 1, right? Or we'll go 2 comma infinity. Okay? Luke, question.
What about the values less than negative 3, because those were positive too?
Say that again.
If you go less than negative 3, they're still positive, right?
Right. Do I have this graphed wrong? I do. I've got to set that up. That's right. Thanks, Luke. I did make a mistake. So let's go this way. Okay, so we got more to it, right? Thanks, Luke. I got to add more to this graph. Nice job, Luke. So we also have to have x is less than negative 3, right? And we also have an interval of negative infinity to negative 3. Thank you, Luke. I almost forgot that one.
Sure.
Nicely done. You're on camera. I'm admitting I'm wrong and you're right. Don't you love that? Love it.
Send it to Simon.
Show 'em.
Okay, now, next example, okay? So, on example 2, what do we have to do, okay? What do our reading steps say? Okay, first, move all terms to the left side. Okay, let's do that. So let's make it a 2x cubed plus the x squared minus the 13x plus 6 is greater than or equal to 0, okay? Now, this one might factor. It might factor, but oh my goodness gracious, I'd rather not factor. So if we want to factor, and you don't like to factor, put a frowny face there, right? Because I know you don't like to factor. What can we use? Jose keeps saying the poly button, right? Because the poly button finds all the zeros. So let's find the zeros by using the poly button, okay? That's not too bad. So on, and I like the poly button because it gets us the exact answers quickly. We could graph it and get the zeros from the graph, but it's not as easy to get the zeros from the graph. Does that make sense? The poly button's the fastest. So if I go straight to apps, poly, we're getting good with calculus, aren't we? Poly Smilt, free advertisement. There's my free advertisement. Enter. Poly on apps. Degree is 3, right? I'm going to go 2, 1, negative 13, and 6, and let it solve. Okay, so it's thinking, right? And there they are, okay? So my zeros, so this would have factored, but you know, it would have taken some real work, are at x equals 1/2, x equals 2, and x equals negative 3, okay? So, graph it. Number line. Alright, and border points at negative 3. You did? I got 0.5, which is 1/2. Oh. Let's check it real quick. Okay, here's what I have. I've got 2, 1, negative 13.6. Did you get that, Elise?
Yeah.
Okay, solve. That's got to think again. Did you get it yet? Okay, good. So I'm going to have a 1/2 and 2, right? Now, solid dots. Solid dots because there is an equal sign here, right? Solid dot, solid dot, solid dot, okay? Now, where do we shade? We're looking for where it's greater than 0, greater than or equal to. So if I graph the polynomial itself and take a look at its wavy shape, I'm just looking for where it's above the x-axis. This is a pretty easy assignment. Do you guys agree? As long as you let the calculator do most of the work for you, it's not too bad. So y equals quit, y equals clear that one out, and I'm going to just do a 2x to the third, and I'm going to go plus x squared, subtract 13x plus 6, and let's graph it, see what we get. Alright, so if I look at the calculator, it's pretty obvious where it's positive and where it's negative, okay? It is negative from negative 4, right? It's negative in this region, which is the negative 4, right? It's positive in this region, right? From negative 3 to 1/2, it's positive. It's negative from 1/2 to 2, and that's positive again from 2 over, okay? Does this make sense? I mean, just looking at the graph, and where it's above the x-axis, it's positive, right? Positive numbers are greater than 0. And of course, where it's below the x-axis, where it's negative. Now, what do we need? Is where it's positive, right? Greater than or equal to 0. So, I'm going to shade then in between negative 3 and 1/2, right? And I'm going to shade from 2 to infinity, okay? How am I doing, Luke? No mistakes yet?
Oh, just fine.
Good. So now, set notation would be, set notation is going to be negative 3 is less than or equal to x, less than or equal to 1/2. Sure, thank you guys. Or we'll have x is greater than or equal to 2. That's my set notation. Interval notation, which I like better. You guys probably like interval notation also. Or I could write it as negative 3. I'm using a bracket because I have a solid dot. 1/2 bracket. Or we'll go a bracket 2 comma infinity parentheses. You got to use parentheses because you can't get to infinity. Not too bad? I mean, especially if you can let the calculator do the work. I mean, it just makes sense. It's above the x-axis, it's going to be positive. Below the x-axis, it's negative, okay? Ready to turn the page? Okay. This is actually not a bad lesson. All right, now, on example 3, we're going to have to worry about dividing by 0, okay? So we take a look at it. And on example 3, I'm going to factor both, okay? Right, so if I factor the top is going to be an x minus 3, x minus 1 on the top. Because I need the multiples of 3 that make a negative 4. Negative 3, negative 1, right? And in the denominator, I'm going to have a x minus 5 and an x plus 1, okay? So here's what I know. I know two things, okay? It is equal to, so if x equaled 3, it would make the whole thing equal to 0. That's a border point. If x equaled 1, it would make the whole thing equal to 0. That's a border point. But x cannot equal 5 because it's going to kick my asymptote, right? You're going to divide by 0. And x cannot equal negative 1, okay? If x were 3, it would make the entire equation 0, because 0 on the top is 0. 0 on the bottom is bad. If it's 1, we divide by 0. If it's 1, that's okay. 1 on top makes it 0, and that's okay. We would need to find out where it's greater than or equal to 0, okay? But these are also border points because these are the things it cannot be. So before I take a look at on the calculator, I'm going to put in my border points, okay? And I'm going to go and have a negative 1. I'm going to have a 1, a 3, and a 5. Now, I'm going to have two types of points on this thing. I'm going to have two types. I'm going to have open circles and closed circles. Okay? These will be closed. Okay, these will be closed circles. Because it can equal 3, because when it is equal to 3, you get 0, and it can equal 0. So I'm going to have a closed dot at 3. And it can equal 1, because when it is 1, it does equal 0, so I'm going to have a closed circle at 1. But it cannot equal 5, so I'm going to have an open circle at 5, and it cannot equal -1. Okay, does that make sense? Now, let's put it in the calculator. Let's take a look at it. We're trying to find out when it's greater than 0, so we want to find out when the graph is above the x-axis. All right, so let's check it out. Okay, on y equals, clear that. Now, remember, I'm going to put it in carefully. Put it up here. I'm going to make sure I have parentheses, so I have the entire top, divided by parentheses, so I have the entire bottom. Entire top divided by entire bottom, okay? So I'm going to go parentheses. You have to do this because you need the entire top numerator divided by the entire bottom denominator. Okay, so let's go x squared, subtract 4x, plus 3 divided by parentheses. Let's go x squared, subtract 4x, subtract 5, parentheses, and let's graph this and see what it looks like, okay? Okay. All right, kind of went crazy at -1, kind of went crazy at 5. That makes sense to me, doesn't it, right? So here's what I have. It is above 0 right in here. So it's positive from -1 back to infinity. See that? It's above the x-axis. Okay, but from -1 to 3, -1 to 1, 2, 3, looks like 1, 2, 3, 4, 5. So all of this looks, I'm not sure what's going on in here. So one of the things I can do, I'm pretty sure from 5 over, if I look at my graph, see 1, 2, 3, 4, 5 over, it looks like it's above. But if I'm not sure, I can use my trace button because I'm not sure what's going on in between here, okay? So if I use my trace button, go to trace, -2, yeah, that's positive. Okay, I knew that. Let's try what's in between here. How about 0? Trace 0, okay, 0, enter. So I get a negative value. And that was kind of hard to see, but I get a negative value in this region between -1 and 1. So negative. So I don't know what's going on in here. Let me try. Let's plug in 2. So I'm checking values. Sure. So let me go back to what I did so you can see it. So I tried -2 and I get an answer of a positive 2. So it is positive at -2. Then I'm going to try 0 and I got a -0.6, so it's negative in this region. Let's track this region. Let's try 2. And I got a 0.11, which is a positive value. Let me check 4. And I get a -0.6, so it's negative in this region. Let me try 6. And I get a positive. Okay, so the reason I like to do that is because I know if it's positive, it is greater than 0, right? If it's negative, it's not. If it's positive, it's greater than 0. If it's negative, it's not. If it's positive, it is greater than 0. Okay, so now let's shade. So I need to shade all of this, right, on the number line. I need to shade the positive region between 1 and 3. And I need to shade this, okay? How am I doing, Luke?
Beautiful.
Good, love it. Okay, so now, set notation. I'm going to say a couple of things. One, I can say that 1 is less than or equal to x, which is less than or equal to 3. And I also can say -1 is greater than x, which is greater than 5. Okay, that's set notation for all 3 of those sections, all right? Interval notation might be a little easier to write. So interval notation will go a negative infinity, comma, -1, parentheses, right? We'll go bracket 1, comma, 3, bracket. And then we'll go parentheses 5, comma, infinity, parentheses. How's that?